CAT interviews at Uber, Confluent, Indeed, and many more companies. I've seen it all. After countless hours on the other side of the table, I know exactly what top companies are looking for, especially in LLD. In this course, I'll share the insider blueprints, what to focus on, especially key design patterns, how much multi-threading, very important, counter question, traps, and how to tackle them confidently. This course is structured, practical, and tailored on what companies are looking for right now. Let's get you interview ready right now. Now moving on next to our next LLD series question, which is design elevator system. Again, it is hard, so please make sure that you buckle up. And again, specifically, I will tell where you should stress your brain and apply your brain and focus carefully. Elsewise, again, you can take it like other problems as well. Now, I'll give a quick idea how exactly we'll go. Firstly, I will explain you what exactly is elevator system, as in, for the folks who are not aware of elevator or lift. Again, elevator, if you have gone to any mall, any shopping complex, the machine or like the thing which lets you go up and down, that is called as elevator. In Hindi, it's also called as lift. Now, firstly, we'll tell what exactly it is. Then we'll go to the actual interview setting. What exactly we want to discuss, we will discuss that part, covering the most common design patterns, design questions. Then we will focus on the very prime logic, which is the actual algorithm of how elevator should move. And that's the very prime part I want you to focus on. And again, I'll explain with the help of proper dry run, example, all that stuff. Because again, for the folks who don't know, we have entirely another channel for algorithms, which is by the name Aramithal. But yeah, we'll go and see three algorithms, three strategies, or you can say, and then we'll go and look at the extensibility, how we can make this code extensible and have more design patterns involved. Just to give a quick idea, this will primarily be focused on the algorithm of how you make sure that you are moving your elevator up and down optimally. Cool. Let's start off with the actual elevator system. Elevator system simply says that, bro, you have to transport people between floors in a specific building, which means you have to handle multiple requests and optimize elevator movement. Not too much, not too less, not letting the people wait a lot. Kind of, you should have the optimal movement of elevator. And again, there's a couple of edge cases: ensuring safety, accommodating different priorities, handling emergency situations. So technically, any elevator should ideally cater multiple floors, and also I can run multiple elevators. Usually you see in any shopping complex, you have around 8 elevators. And again, like depending upon how big the shopping complex is, if it is higher or bigger, or maybe based on how the dimension is or how the thing is, it can be different. Now, so obviously I can have multiple elevators in a building and they will be catering multiple floors. Obviously, elevator can be called from any floor, and I could travel to any floor. Now, although I will explain that in future as well, but giving a quick small disclaimer that I'm not sure which elevator you're aware of. In this video, we're going to discuss about the elevator in which from outside, you can just see a up and down arrow. And as you go inside, then you can see a number pad, which floor you have to go to. This is what exactly we'll be discussing on. And you will see mostly this is the most occurring version. Now, why I am saying that, giving a quick disclaimer, because in my office, usually like back in Goldman, we had elevator in which externally, which means outside the elevator, we had a number pad in which we used to put the number where we have to go, and then we used to get the lift. We will not discuss this one because this is not that much traditional. Traditional is this one, where you just only have up and down arrow outside at every floor. You just click one, and then inside the elevator, you have the actual number pad where you have to go. Cool. Coming on back to the main problem. Obviously, we can have some couple of edge cases like maximum capacity or how the elevator move, based on the request and optimizing for efficiency. Now, obviously, as I mentioned, that user can request any elevator from any floor by pressing up or down buttons. That's it. User will request by only putting up and down buttons. And obviously inside the elevator, user can set their own destination flows. And as I mentioned, there is also other kind of elevators where you not like where you don't press up or down, you actually press the buttons. But again, we are not going ahead with that. Now, elevators will have indicators which will show what is the current floor. If you don't know, all the elevators have a number either on top, as in like outside. Outside, you will see that there's a plate on top which shows at which floor this lift is. So that you can see if it is coming up or if it is not coming up, and so on and so forth. Usually, you will see also here itself, just above the up and down arrow, there is kind of a digital system which shows at which floor currently this actual elevator is. That's exactly what we are saying, that it shows the current floor, and obviously you can also see a direction it is coming up, and so on and so forth in this display. Now, obviously, some of the emergency features like emergency stop, overload detection, and tow sensors. Now, this is exactly an idea of an elevator system. Now, let's jump on to the actual interview setting. Interview simply mentions design an elevator system. You will jump on to with an idea of what you have. As I had been mentioning previously in all the problems before as well, that enact the system. Inaction of the system says just do the exact same thing. Inaction says that firstly, when I as an admin will make an elevator, I will have a display. A elevator will be there. Elevator will have its own, corresponding stuff. A display could be there. A up and down button could be there, and so on and so forth. Obviously, elevator should cater all the floors. Elevator will be inside a building. A building can have multiple elevators, and then a consumer or a customer will come in. He will just request. So obviously I will have an elevator request. He will just say I want to go up or down. Then I should have a elevator controller kind of something which will make sure that I control the elevator movement based on the customer's request, and based on his elevator request which is given by my customer, I would be easily able to say, okay, which elevator should come down. And out of all the elevators, okay, this one should come down, and this is what I have to go inside. After going inside, I will put up the corresponding request. So basically, kind of the movement of the elevator will go by its own strategy, that how it should be moving, technical strategy, technical how the elevator should be moving, because obviously there can be multiple ways as we'll see ahead. So yeah, this is the entire idea. It is enacting of the process. The person firstly made, then a customer came in, he standed, like he pressed the button, he saw something happening, then he went inside, he pressed another button of floor, then he went inside, and then he just went out of the floor. Sorry, went out of the elevator. Cool. So the same thing that putting down as points. Now, if you are confused what this inaction means and you want to just go, please make sure that you're following the series. Cool. Going ahead, we will say that we have multiple elevators within a building, and users will simply request elevators from different floors, obviously. And I have to optimize elevator assignment, which means obviously I will have some elevator movement strategy which I have to take care of, because I have to minimize my wait times. That's the primary thing. And that's the thing. That's the main important thing, which will kind of push you towards a DSA, or how optimally you can think of that elevator should move. Because for the folks who don't know, and for the folks, again, I'll explain you the problems, that how starving kind of problems can come up if you don't optimally choose your elevator movement. But cool. Then a couple of edge cases, for example, safety features and scalable for different sizes. Now you can simply ask that couple of questions, couple of clarifying questions, that how many elevator I have to go to. Like, is there any specific elevators like service elevators or express elevators, and how should the system optimize elevator assignment? Because that's the primary thing, kind of, right? So maybe like the interview will say, okay, like we want to support multiple elevators, which is they want service elevator, express elevator, or normal elevator. And obviously I can have any number of floors, and it should handle both external request, which means up or down request, or the internal request, which is go to this floor, go to that floor, and obviously efficiently schedules elevator movement to minimize the wait times. That's the thing. Although we will see many strategies of how elevators should move or would be moving, or we can just run at the runtime, but that's the idea. So I'll just summarize all the points and taking the points from my interviewer as well. Now, going ahead, let's start off with the same flow. Now, the flow simply says, again, for the folks who are not aware of how we have been going ahead with the flow here is, firstly, we discuss a couple of entities. Again, although if you just focus on, we already discussed a couple of entities here itself. We had an elevator, we had elevator controller, we had the user, we had the elevator request, we had the building. That's it. Then, after discussing the entities, we discussed design patterns, which we can use here. Again, although we discussed many of them, but not necessarily we implement all of them. We might discuss factories, strategies, singleton, so on and so forth, but not necessarily we implement all of them based on time and importance of a specific design pattern. We will tell or verbally tell about all of them, but we will stick to, let's say, one or two of them. And obviously, in this case, the primary task is efficiently moving of the elevator such that you don't go on to starvation. Again, for the folks who don't know starvation and the folks who haven't ever seen any elevator algorithm, or for the folks who have seen some random YouTuber's video about elevator, you will know how exactly to solve this elevator problem. Now, then obviously we will discuss the actual algorithm for elevator. Then ultimately in the end, obviously we'll discuss the entire code implementation. Then in the end, we'll discuss extensibility, where we will, let's say, use factory, we'll show a strategy, how we can extend the code, and so on and so forth. Cool. Again, we will stick to the point, we'll stick to the problem. That's it. Now, obviously, we have an elevator, right? This is the entity which we had. Now, we knew that an elevator will have, its corresponding name and entities. Obviously, a ID will be there, a floor, because elevator will be standing at a specific floor, and elevator will go onto a floor that's closely to it. An elevator will have its direction, how it is moving, so direction to it. Elevator will have its own state. I'll tell state what state is, but obviously it is idle or it is moving, it is stuck, it is in maintenance. Many states can be there for an elevator. Obviously, as we are mentioning, that elevator will have a number pad to it. Outside, you will see there will be a display. That there is nothing but an observer. Obviously, someone is observing that specific digital pad. So obviously I will have, again, although we will see that more in design patterns when we'll discuss, but obviously I will have some observers which will be observing it. Now, why I took as list? Because, okay, one thing is right now is one display observer. I could have, let's say, another monitor inside my central control room which observes all elevators movement. So obviously I could have on my phone as well. Let's say if I am in a specific, my own house has four elevators. I want to observe, I can do that as well. So that's the reason I'll just have a list of observers. And then the primary thing is the requests. Obviously, as we were saying earlier as well, that all the requests, we can just name it as elevator request. Now you might say, Aryan, why exactly elevator request as an object? You will see, no worries. But yeah, that's a kind of an idea. Now, obviously, I knew this thing, so it is the reason I was able to come up very fast with this. Okay, just perfectly giving all the corresponding attributes. You don't have to do that, and it's not expected as well. As I was mentioning previously in the previous questions as well, you can go step by step. Let's say if you just only can think of ID and direction and current flow, just keep them. Okay, keep ID, keep direction, keep current flow. That's it. Maybe you can ignore these as well. Completely fine. Now, obviously, this is kind of a representation of that elevator will have a direction. Elevator inside it, you will kind of going up or down. So you can request some flows that a number pad will be there. Obviously, I will have some observer to it, and so on and so forth. And again, there are a couple of helper methods. As I was mentioning previously as well, you can just use Lombok, or maybe if you have time, then in the end, write these getters and setters. Now, another attribute or another entity will be building. Again, obviously, building will have some flows. Building will have its name or ID. Again, you can give ID as well to it. And obviously, building will have an elevator controller. Now, you might say, Aryan, building elevator controller doesn't make sense, right? Yes, it doesn't make sense because technically there should be a building controller, because obviously a building is there. It has multiple elevators to it, right? So there should be a building controller which controls this building And inside that building controller, it should have an elevator controller. That building controller will ask elevator controller, bro, what is happening to this elevator? You tell me. Cool. Or maybe you can say what is happening to all the elevators. You tell me. So again, why building controller? Because obviously for a specific for a specific, any mall or any this kind of a place, only elevator is not the thing which needs to be controlled. There will be escalators as well. There will be shops as well. So all these controllers technically should lie inside my building controller. But as we said, we have to stick to the main thing. Verbally, I can tell that I should have a building controller, then which should actually have a building and elevator controller, which means that elevator controller should ideally not come up here. But it's okay. It's okay to verbally tell this and then proceed ahead, because right now we haven't even touched the main portion, and the time has already elapsed a lot. Cool. Obviously, we're going to floors, so I just have made floor as well. So floor will have its own floor number, and that's it. Now, obviously, I will have an elevator controller which will manage my elevator operation and scheduling, which is the kind of, all the elevators are kind of managed by this elevator controller. That's it. That's my elevator controller has only a job of managing all the elevators. So again, obviously, when I say elevators, I'll just say, okay, what floors are linked, with this elevator, because obviously elevator controller will see what all floors I have to cater and what scheduling strategy I should make sure of. Now you might say, what does this strategy come up here? It is kind of that obviously an elevator is there. Now how it should move. When I say how it should move, imagine that you have multiple requests coming up. You have a request that, okay, I have to go to floor 2, I have to go to floor -1, I have to, when I say -1, it is basement 1. When I want to go to floor 5, I want to go to floor -5. -5 is basement 5. And then floor 10 and so on and so forth. So how to move between these requests is what my strategy will define. Although we will see that as we go ahead as well, but it is very, very normal as we refer to payment strategies, that how I want to pay via cash, card, UPI. Same way, how I want to move. I want to move sequentially, I want to move jumping, I want to move in a circular way, I want to move in a round robin way, I want to move in a scan way, I want to move in a look way. Many ways can be there for movement. And that is your strategy. Scheduling, how your this elevator should be scheduled. Now, obviously, I can give the elevator ID as well. Okay. Now, anything else? I can have a couple of enums which will help me a lot. I can have direction, up, down, or idle. I can have elevator state, as I was referring earlier, if it's idle, moving, stop, or maintenance in maintenance mode. Now comes the fun part. Again, so far, if you just see that we have seen enums, right? And then we have seen main entities. I have seen an elevator. Obviously, elevator will operate on a floor. It will be on a floor. Obviously, I will have a building, right? Right now, we have put up elevator controller inside a building, but obviously, I will have an elevator controller, which will control these elevators, right? What else? I have elevators, I have elevator controllers, I have the floor, again, I have the building, and again, primarily couple of enums. That is what primarily we saw. You see that floor, building, and my elevator, and that's it. Now, again, I'm not saying that these are the only ones which is required, but we are good with it. As we can now go ahead to our actual design patterns. So design pattern will simply say that, bro, what you can use. Although you could have simply seen by far, we'll use observer so that I can see at, what I can observe all the elevators easily. Then I'll use command pattern. This is for primarily the request processing. Now, why this case and is it necessary? Not that much. But if you wanna, please go make sure that you have gone through the design pattern series previously. Coming ahead, I can simply say that each request I will treat as an object. So if you remember, I was saying that I will have an elevator request. A consumer or customer will pass in or will say that, bro, this is the elevator. My writing is why so bad. Okay. Elevator request. This is the request which I will pass into my elevator. Now, why as an object? Because obviously it's a request. Request can be of two types, internal or external. In that also, it can be, if it's internal, then obviously I will have to put up a button, floor, go to floor 4. If it's external, then go up or down. So obviously, and again, from which floor I'm requesting it, that's also required in the external request. So all that I just put up as a command pattern. That okay, I can just encapsulate each request as an object. Obviously, the main down here, which is a strategy, which will say the scheduling strategy of my specific elevator. Just give me that. So now we club everything together. So firstly, I have my strategy, scheduling strategy. Although they can be literally many, we will see very basic FCFS first. Simple FCFS. First come, first serve basis. Then we will see scan, a bit better than that. Then we will see look, bit more better than that. Am I saying is it the optimal, most optimal one? Not necessarily. Is it the one which you should tell in interview? Yes, absolutely. Can someone argue that there is much better one? Maybe. Will they argue? Not really. Did you see that? Yes. Because again, there is no specific algorithm for elevators because it is very highly optimized on the basis of machine learning. So again, if you think no elevator has very that elevators which you feel like they are kind of moving with the look algorithm, they will be your flat as in like your apartment elevators. But usually in multi-complex or all these big places, offices, multi-complex and all that stuff, they have machine learning involved to their algorithm. Now we have done strategy. Anything else? Again, now you might ask Aaron how to make the class diagram. Obviously, if you are asking this question, which means you have landed onto this video directly, which I will not recommend. But still, we always make from a bottom up approach. So, okay, my strategy is done. Then obviously, I will have my observer. So I will have an elevator display for observing it. Then obviously, I will have my elevator request for command. What else? Now make the main entities. I will have my elevator. I will have my elevator controller. I will have my building. Anything else? Obviously floor. I can have my floor. Anything else? There are a couple of enums which we can ignore as well. But yeah, this is how exactly again. Did you see how simply we were able to club all this together? Now you might say, Aryan, but how would I know these arrows and stuff? Simply are that elevator controller which will manage elevator will be on a floor. Right now, although we should have a building controller which should handle building and elevator controller, but right now we are saying okay, building only will actually handle my elevator controller. So you see that how easy it is to kind of relate with each other. Now come to the main point: individual contribution or individual implementation of the individual design patterns. We will firstly go on to observer, right? Sorry, go on to the observer. Then we will go on to my strategy. Again, obviously, this is the request which we will make, obviously. So let's go on to the observer. It will say elevator observer. Now observe when? Observe if the state changes from moving to idle. Remember that, yeah, when the elevator state changes, then observe it, or when the flow changes, then maybe observe it. Let's say if my elevator go on to the maintenance state or kind of stuck state, then I should get the alert right on my phone. Yes. If the elevator moves between floors, then I should show that on my display, right? Yes. That's the reason I can just have main observer methods. Now, obviously, I will have the concrete implementation. Let's say elevator display, which implements my elevator observer. And again, right now, just a simple dummy S out. Simple dummy S out. Business logic can come up here. Now, obviously, as you're mentioning that the biggest thing is request processing. Elevator request is the biggest thing in this entire problem. So make sure that we cater that. So I will say that I have an elevator command which should execute. And again, my primary thing is elevator request. Now, ideally, this should have been an abstract class. Again, I'm saying ideally in a production code base. Do I have time for it? No, I don't have time for it because I want to save my time. So I'll tell verbally that ideally in elevator request, I should have internal elevator request and external elevator request and then cater that separately. But right now, I have taken simple one variable is internal request and then I am catering that. Now, why it's an issue? It's an issue is because obviously is internal request. If you see very carefully, as I was mentioning earlier as well, if for any elevator, for the person who is asking for the external request, he has option up or down button. That's it. And also his current floor. His current floor. For anyone who is asking for external request, right? External request, sorry, internal request, he will go inside the lift and then press a button, which is destination floor or target floor. Destination floor, target floor. That's it. So both of them are catering different variables. He needs direction and current floor. He needs only destination floor. So request direction and also the floor I have is technically needed for external request. For internal, obviously, as I move inside, I will put up the internal request. Okay, I want to go to here. So that's the thing, that it's kindly, kind of a bit of not okay, you have just clubbed everything in this. Not necessarily good practice, but okay, we are still good with it. Obviously, we have to implement or execute, like implement, or I should say override this execute method, which will say if it's an internal request, then go ahead and ask a controller to request for a floor. If it's external request, then ask for a elevator that which can come up at my floor. Come up at my floor. And again, if it's an internal, like if it's kind of internal request, then I want to go to this floor. If it's an external request, then I want to come at this floor. Like say, yeah, please come at this floor. Here, if it's internal, then go to this floor, reach me this floor. If it's external, then bro, I want to go up, but I'm currently standing at this floor. Again, you can take another variables as well, totally up to you. Now, the elevator request is sorted. Let's come on to the very, very, very important part, which is the strategy. Different scheduling strategies. Now, first of all, I will say that, bro, I have only one job. Get me next stop. What I'm trying to say here is that for me, if this is an elevator, if I have multiple people standing inside or even let's say outside at some different floor, they press in, let's say they were demanding I want to go at floor 5, then floor 2, again like when I say floor 5, floor 2 for like let's okay let's say like this. He wants to go at floor 5, he wants to go at floor 2, he wants to go at floor -1, he wants to go at floor 10. And he say that okay, I'm standing outside, I am at let's say floor 3, I want to go up. So these are all the requests. Considering all these requests in mind, how should this elevator move? Or what should be his next destination? Should he go to 2, -1, 5, 10, 3? Which one? That is the question here. So, next stop is what I have to find. Out of all these stops in mind, I have to find my next stop. Now, first come, first serve basis. It's the first strategy. As the word itself says, whoever will click first, I will cater that person. That's it. Period. No more, nothing less. Okay. To take a better example, let me simply go down and copy this thing, which is kind of a big example which I had made previously for you guys. Again, pardon me, this tablet is pretty slow. It's pretty old. Yeah, it's actually a Windows, Android tablet. So yeah, we'll have a couple of hiccups, but no worries. We have our example right here. Cool. So, okay, I have to kind of paste it here, then drag it back here. Okay, cool. So now we realize that in the first come, first serve basis, do exactly what they are saying. In the FCFS, simply get me the elevator direction, how it is moving. Simply get me the elevator direction, how it is moving, right? No worries on that part itself. Get me the current floor also. Okay. Get me all the requests which you have. Okay. If you have no request, then stay at the current floor which you are at. So this current floor is the current elevator floor. Elevator is simply standing right now here asking, where should I go? I am telling, bro, you have no request. You stay. You stand here only. Don't waste your energy. Now I will get the next floor directly from my queue. You will say, what is this queue? No worries. Although we saw also previously that elevator contains a queue of elevator request. So I'll just get my request, and from that request, again, first request, and I'll get the floor. And then I will check maybe if it is the same floor I'm standing at. If not, then I will check if I am at the ideal. If I am standing and it's ideal, then I'll set my direction of the elevator. Else, if it is I'm going up and my next floor is kind of down than my current floor, then put the direction as down. Or if it is vice versa, then put up. So this entire portion is giving the direction to an elevator. Is it required? Not necessarily for you, because you have already got the next requested floor, which is directly catered from your request queue. So what exactly happened? What exactly happened is, in the scenario, imagine, again, I will use the same example for all these strategies. So make sure that you focus on that very carefully. That's the point. You have to make sure very carefully, because again, you will not find it anywhere on YouTube, and that's the thing. That's what make it much of a interesting problem. Imagine you as in the elevator was at floor 5. At that time, there were 6 people standing in front of the elevator, right? They came inside the elevator and they pressed. First person who pressed the button was, he pressed -1. Next person pressed 8. Next person pressed 2. Next person pressed 6. Next person pressed -5. Next person pressed 10. Again, make sure. This is obviously, I am keeping them sequential. This is how they pressed in the sequence. Although they came directly at the same floor 5. But this is how they pressed their own buttons, their own destination buttons. Now, again, I am saying that make sure you follow it up. As soon as they were done pressing, before even the lift could start moving, the person at floor 3, the person at floor 3 requested he want to go down. The person at floor 4 requested he want to go up. The person at floor -8 is basement 8, request he want to go down. So this is, again, right now I'm still standing at 5, right? Now I have a mixture of internal request and external request, both in the queue of elevator request. So this is a queue. This is a queue of request which I have. What the first come first serve algorithm says that, bro, I will firstly go on to floor -1 from floor 8, then I'll go to floor 8, then I'll go to floor 2, then I'll go to floor 6, then I'll go to floor -5, then I'll go to floor 10, then I'll go to floor -5, then I'll go to floor 3. Obviously, at the floor 3, the person just mentioned I want to go down, which means that as soon as he will enter inside the lift, he will again press the button of where exactly he want to go, because it was external request. It doesn't mean that this person's destination is 3. No, it was the source location. I picked him up. As soon as he enters, he let's say put up that I want to go at floor 7. Then I just put up inside my queue. And then I will, cater 3. Then I will cater 4. And in this sequence only, I will keep on catering the request. Right? And this is called as first come, first serve basis. Is it a good algorithm? Obviously not. But this is first or very basic algorithm of movement of elevators. Next, let's go on to the scan algorithm. It will scan in one direction and get you the corresponding next elevator. So what this scan algorithm says, let's again make the same diagram. And with that, with that, we just simply shift it right. And I am screwed up. No worries. Okay. So scan simply says that, bro, you do a scan and then go in one direction only until the requests are completed. So again, you implement the same method. You will find your current direction, whatever it is. Then you find your current floor as well. Then you will get all the requests which you had inside your queue. Then if there is no request, stay at the current floor. Now, now comes the fun part. Fun part says I will use a up queue or a down queue. Up queue as in from my floor, current floor, what are all the requests who wanted to go up? From my current floor, what are all the requests who wanted to go down? Right? Why a priority queue? Is it required? Not necessarily. Because I am linearly iterating through all the requests. So technically, I can solve this without priority queue as well. Why? Because I just want one floor. That's it. Now you might ask, Aryan, then why have you taken priority queue? Just to show that people might take it and it's okay because it's not an algorithmic problem. But still, you will see the next strategy which we will see, which is the look. Again, this is scan. Next one is look. Look one is much better than scan one. Again, don't go by names. People use names interchangeably. I also use name interchangeably. The internal algorithm matters because again, scan, look, both are kind of, I'm scanning, I'm looking. It doesn't make sense even the name. So keep the names as okay, like as take the names lightly. The internal algorithm is much more what is important. Cool. Coming on back, we will say okay, I'll take priority queue. Why? Because obviously, right? If you're starting at the current floor, if you have, let's say the floor is 5, and I have the request to go to the floors, let's say 6, 7, 8, and 10. I have request to go to my down floor as 4, 3, 1, -1, -5. So if I plan to go up, I should make sure that I'm going up in this order. Firstly 6, then 7, then 8, and then 10. There is no point of going to 10 without even catering 6 or 7. Because for me, I just have to give him a next stop, which means I will give him 6 and then I will go. This function will end. His only job is to give a next stop. That's it. Coming on that, okay, what I did, I just simply iterated on all the requests. So what all requests I got from this step, I just iterated on them, and then I just simply put up that all the flows which are above me will go inside the up queue, all the flows below me will go inside the down queue. Now, if I am idle and I have nothing to do, which means I have no direction as such, so I will find what is the closest floor to me and then I will start moving towards it. So if I got some request, let's say I'm at floor 5, I got request and inside my up queue I have 8, 10, and let's say 12. In my down queue I had 3, -1, and -5. So you will see the closest here is 3 from 5 rather than 8. Considering if it is idle, then he will go to down first. That is the entire logic here. He will go down first, obviously, when he's idle. But if not, then there is a slight catch. If it is going up, it will keep on going up. So until the up queue is empty, bro, if the up queue is not empty, then obviously up queue, which means if you are going up, then keep on going up. If there's nothing to go up, then you go down, which means you switch the direction and then you go down. Obviously, same way, vice versa, that if you are going down, then keep on going down. Get the next floor to down. Obviously, if not, then switch the direction and go up and take the up. When I say switch, it obviously sets the direction and also it gets me the corresponding floor. And if there is no floor, then get me the current floor. Now let's see the dry run with the help of our standard example. At floor 5, all these folks come up as internal request, right? And then I got some more requests as the external request. So at this point in time, my request queue contains all these requests. Obviously, you might say, I'm standing idle. Yes, you are standing idle. What you will do? Obviously, you will pick up the floor which is nearest out of all these floors. Right? So you will pick up 4. And then again, you might say, what about 6? Yes, both are same. But you will see a small catch here, right? there is no distinction between internal and external request. Both are treated equally, which obviously is actually an issue, and we will cater this issue in the next approach. But yeah, here both are treated equally, which is obviously bad, but yeah, no worries. So you will see that here in this logic, that based on the logic, however you have, you can pick up anyone which when you have equal, when you have equal distance. Now coming on back, when I say equal distance, I'm using equal absolute distance. Coming on back, that imagine it was going down. Imagine it was going down. So obviously, I will segregate these requests as the request below it and above it, right? Out of all the requests. So I will simply say that bro, -1, 2, -5, 3, 4, and -8. 3 going down and 4 going up and -8 going down. Okay, and these are down request or down queue. Up queue will be 8, 6, 10. Cool. Now again, imagine, although I showed you that if it would have been ideal, then it will pick up the closest one, which is kind of both 4 and 6. So it can pick up any one of them. But let's say it would have been going down, then it will go down up till the end. Which means if it will go down up till the -8. Is it good? Obviously not, because this person, or let's say even this person who pressed 8, he will be saying, oh, what is happening to me? Why am I going so down? But yeah, this will happen. It will go ultimately very down up till the last request, because if it is going down, it will keep on taking all the requests up till he can go down. And the worst part is, and why this is not a good algorithm, again, obviously you saw FCFS is also bad. But this is also bad because what if there's, next person who also wants to go down, next person who also wants to go down. So literally, as he's going down, and in that time itself, if another request came up who again want to go down, then this 8 person, like the person who wants to go to 8th floor, he will go in starvation. He will go in starvation, which means that if I am at floor 5 and the bottommost floor, let's say floor -20. So technically, after going to floor -1, he should have gone to floor 8. After going to floor -1, he should have gone to floor 8. But because I got so many requests of floor going down, I ignored this person, which is bad. But again, this is what is happening in the scan approach. That you will keep on going down until you get the request. If they're exhausted, if they're completed, then you will cater the opposite direction request. And same way, if this would have been going up, then I would have catered all the requests going up first. When all are completed, which means extreme end one, when it is completed, then I will go on and cater the request going downwards. Again, obviously in a sequence. Firstly 6, then 8, and then 10. Obviously, when I'm coming down, then I will cater 4 first, then 3, then 2, then -1, then -5, and then -8. The requests are catered in sequence, but it is catered firstly entire up, then entire down. And that is again an issue, but yeah, this is your scan algorithm. Now, can you do better? Yes, obviously you can. You will use look strategy. Now again, don't go by name. Name is literally bullshit. But yeah, this is much better. This says that I will not let you go in starvation. And I will consider both the request internal and external differently. How? Let's see. So it says that obviously, bro, at the floor 5, you got the request like this, right? Yes. So ideally, you currently at this point in time have a request of going to floor -1, 8, 2, 6, -5, 10. And again, all these requests came in a sequence, that this came after it, this came after, previous one, and so on and so forth. So ideally, I should cater the sequence itself. Now, the look algorithm says that, bro, I will cater, I'll respect their own sequence. So at floor 5, I will obviously firstly make sure that I will cater -1, right? Does it mean Aryan I will go to -1? No. But his task is right now, he will cater only the first element, which is -1. So, but if you remember, my strategy should only return me a floor. Next stop. So can I directly return a minus 1 as the next stop? No. Then it will become FCFS. Is it FCFS? No. So this will say I have to go to minus 1. This is my target destination. But as I'm going to minus 1, obviously I will find many other places in between. So from 5 to minus 1, I have 4, 3, 2, 1, 0. As you can see, I have 2, I have 3, I have 4. So I have these 3 flows in between. At which one should I stop? Should I stop at 4? Should I stop at 3? Should I stop at 2? Obviously, you might say, I'll obviously stop at the first floor. Yes. Let's say if you stop at the first floor. Bro, but he wants to go up. What he will do by stopping at your floor? You are going down, right? You are going down. He wants to go up. Even if, again, I'm just taking a hypothetical scenario. Even if you open the gate for this person, right? Even if you open the gate for this person, and let's say he entered, you will unnecessarily waste his time and you will let him go down, and then obviously he has to go up, which means he has to go above, beyond 4. So you will obviously come back. You will obviously come back to go above. And then you will obviously surpass 4 and then make him reach his destination. Let's say if it would have been 6, then you would have let him reach to 6. Isn't it literally a most bullshit idea? If you were coming up, then why did you waste his time? What if some other lift would have been ready? Then he would have gone to that floor. He would have gone to like that specific lift, that specific elevator. You literally, again, if you feel like that maybe he might not get that specific lift, no worries. While you are coming up, then stop at this place and then let him in and then let him go up, right? So it is literally very bad idea that you are going down, as in like lift is going down and someone wants to go up and you let him in. So I will not let him in. I will not stop at lift 4, but I will stop at lift 3 because he said he wants to go down and I'm also going down. So I will let him come inside. Now you might argue, Aryan, but okay, you will let him come inside. Okay, so 3 person came here. So I stopped my lift here, right here, and this person came inside. If this person came inside, then you might say, Aryan, the assumption which you had is he wants to go down, which means obviously my target was I want to go minus 1. But I have to return the first person where I will drop. So this get next stop function will return floor 3. Okay, let's say you stopped at floor 3, and again, as soon as you stop at any floor whatsoever, you will remove that from your queue. Now you might say, Aryan, removing something from a queue is very high in complexity. Yes, I know that part. You can use any another data structures as well, but right now the algorithm is much more important than the data structure. Obviously, because it's a mixture of LLD plus algorithm. Time complexity doesn't matter that much here. So let's come back to the algorithm. So you said that, okay, Aryan, you just let this person in. What if he wants to go to floor minus 20? Will you let him go to floor minus 20? No. And that's the catch. As soon as I stop the floor here, which means that this get next stop function will return me this floor, which is 3. And as it returned me this floor, I will literally stop at this floor. And when I stop it, I will remove this from my queue. It's gone. And obviously, because he was the external person, as soon as he entered, he will press that, okay, I want to go to this destination. So let's say if he pressed, again, you can guess any number. Let's say if you guessed a number, let's say he wants to go floor 0. Okay, let's say he wants to go floor 0. So let's say he wants to go floor 0. Okay, again, this is an internal request. Now, few folks might argue that, Aryan, what if he wants to go floor minus 20? Okay, let's take that as well. Let's say if he wants to go floor minus 20 as well. Let's say if it is his internal request. Again, I am assuming that, let's say 2 people entered inside, let's say at this floor in time, and one wants to go at floor 0 and one wants to go at minus 20. Let's see what will happen now. Okay, 3 is gone. I stop at 3. Again, I will check the first person in the queue. Who is it? It is minus 1. So I am standing at 3 right now, but still I have to go to minus 1. Again, my target is still same. My target is still catering to the first person in the queue, minus 1. So, okay, I will cater him. and I will try to go to the -1. So obviously from 3 to -1, I have these three destinations. So I will say 2, 1, 0. Who all I have? I have 2, I have no 1, I have 0. Obviously 2 is the first person, and because 2 is an internal request, so there is nothing he has to do, like, because again 2 is an internal request, which means just open the gate at 2 and let the person go out. That's it. So I will stop at floor 2, I'll open the gate and I will let the person out, which means person is gone. Okay, now again, which means that you got the next step or the next stop as 2. Okay, let's say the process continues. Again, the front of the queue is -1, which means again that you have to go to -1 only. So now you will again try to go to -1. Obviously, you will see that the flows between 2 and -1 is 2, 1, 0. Do I have any numbers? Yes, I have 0 inside my queue. Okay, I'll just extract. Again, it's an internal request. So I will stop at floor 0. So this will return me a floor 0. Okay. With that in mind, this will be removed. So floor 0 is removed from the queue. And let's proceed forward. Again, check the front of my queue. It is still -1. So my still target is -1 right now. Although you will see, I stopped at many places in between, but my target still remains same. It is -1 only. Okay, let's proceed forward. Okay, there is no one between these two flows, so I will reach finally -1, and then as I reach it, I'll open my gate and I will remove it from my queue. Now comes the fun part. Now you are at -1 floor. You will check who is the next person. Next person is 8. So now you will go to the floor 8. So floor 8 is now your destination. That is now your aim. Did you go to floor -20? No. Did you go to floor -8? No. Did you go to any other floor? No. So this is how we just solved it. Okay, let's see how we will do it. Now you might say, Aryan, but obviously, like, this is now going down, and unnecessarily you let him come inside. Yes, that's a caveat to it, right? That is the reason that, like, there's a small caveat to the elevators who have just a button up and down, is because you never know how much down. So the most advanced elevator right now which have come in, as I was mentioning earlier, as what is also in my office, they actually say that, bro, you want to go to which, if you want to go to down, then which down, which floor. And that is much more better to estimate that should I let him in or not. Now you might say, Aryan, you let the person in who wants to go to floor -20, but now you are going up, there is no point to it. Yes, he might exit here. He might exit at this floor. And again, because I make him reach at -1, he can maybe exit here. And maybe he can take another lift from here. But yeah, there's a small catch to this one, that ideally he has to cater the remaining request and then he can come back, because he put the request and before him there are other people waiting. I cannot let them wait because of him, even if there's a small distance to it. Again, because of the small distance logic, we took scan. Scan just keeps on going, because obviously if I'm going down, then going down a bit more is not a big deal. That's the reason scan will be there, and that is the reason you have to discuss these algorithms based on, again, how comfortable your interviewer is, or how much brain your interviewer has, because obviously not everyone can understand this algorithm. Now obviously I'll cater 8, but as I mentioned, before going up, I have options of 0, 1, 2, 3, 4, 5, 6, 7. So all these 6, like 6 can be catered, 4 can be catered, and that's it. So these 2 can be catered. So obviously I will try. Okay, 4. I can cater 4. Yes, I can do. Why? Because 4, I'm going up. My tentative direction is up. He also wants to go up. I should let him in. So I will stop at 4 and I will return 4 as the next step. I will remove it. From 4, again, that you still have the target as 8. Again, you will see 6 coming in between. You will stop there. You will stop there. You will remove it. Again, the target is still 8. Again, there's no one else in between from 6 to 8. So 8 will be catered, and that's how 8 will be removed. Next floor is -5. Yes, you will cater that. So now repeat the same process and go down. You might say, Aryan, then obviously we could have gone just 2 more and we could have solved this issue. Yes, and that's where machine learning comes in. That you can just cater these requests as well. Again, you can make it more complex algorithm, totally up to you. You want to put up edge cases, distance based. I can put up the edge case as well. Okay, if the if the threshold is less than 2, then just give that liberty to go a bit more up. So all these can be a edge case or thresholds or some kind of hacky cases which I can apply. But this is how exactly your look would work. Now let's see the code. Exactly same as what I discussed. I will check my queue. Again, I know the video is going a bit long, but it is important because no one discusses it and people are very confused. And obviously, you will see I've marked it as hard as well because of the sheer, extensibility of how the algorithm is made up. So obviously, we will get all the requests inside my queue. Then I will check that if I have no request, then okay, I should share the current floor. But I will then check my primary request. Primary request is the first request, which is kind of my target request. I am aiming to reach there, but obviously, will I reach there or will I go there? Maybe one day, but I could maybe find out some other flows in between. So I will check, okay, what is my current direction? I want to know I'm standing at the current floor. I know my primary request or my target floor is standing here, which is -1. I'm standing at floor 5, which is my current floor. My target or primary request is floor -1. I will check what should be the direction. Obviously, the direction will be down because my primary floor is less than my current floor. So I should obviously go down. With this direction in mind, I will figure out what should be my candidate floor, where I should actually stop, and that only I will return. Right? Okay. So I will say the candidate floor will be the floor which I will find. And as I mentioned earlier, I will go to all the requests inside my queue. I will find their floor. Every request will have a floor to it where they want to go. Again, if it doesn't have a floor, obviously it will have a floor, right? If it's an internal request, then as I mentioned, it will be floor where he wants to drop back. If it's external request, then where he wants his pickup to be done. Cool. Now I will check if the travel direction is up, the requested floor, which is being requested, right? This floor, if it is also up, and also the requested floor is less than my primary floor, right? Let's say my current direction of movement is up. My current floor, this requested floor, which I am kind of current request which I have. This is the current request. If this current request is, let's say, 6, my target, my primary floor I wanted to reach was 8. Yes, I can stop at 6, but I can stop at 6 if it is internal, right? If it is external, then I should make sure that his direction also should be up only. And that is how I will say, bro, now I have got a candidate. And obviously, I want to minimize, which means if I have 6 as a candidate, 8 as 7 as a candidate, or let's say 5 as a candidate, and I'm starting at, let's say, 4, I should reach or I should take the minimum one. If my requested floor, if it is lesser than my candidate, then obviously minimize the candidate who will be first stop to stop there. And again, exactly the same logic if we are going downwards. Exactly the same logic here, right? Again, all these nodes and stuff will be visible on websites. You can just click on, as you can see, parking lot is already there. As the videos will come up, these will also be published here as well. No worries on that part. Now the 3 algorithms are literally finished. Although in the end, I will show 2 more, but I will literally not go into it. They are unnecessarily made just to explain that how strategy design pattern can be extensible. Now coming back to the main entities. Okay, the video is already a bit long, but yeah, we will just wrap it up soon. Elevator will simply say that, bro, obviously elevator will have elevator request and also the observers. Again, I will add observers or remove observers. I can notify on a state change or notify on flow change. And obviously I can add the request inside my elevator. So elevator request will be added inside my request. Cool. Now, again, there are a couple of catches which I've done just to put the directions also, because obviously direction just, giving a direction to a corresponding elevator, that how it is moving and where it is moving. Kind of helper method you can imagine as that. Obviously, this elevator will also have the methods as move to next stop, where I will pass him the next stop and he will replicate that, floor by floor movement. That is kind of a replication happening here. This is just kind of replicating that, okay, moving to the next step by step replicating, like here. And then I will have complete arrival. This will simply say that, bro, as you have arrived on a floor, remove that from your request, so that you have that removed, as I was explaining that Tyron as well. Same way, others get as methods, which obviously you can do it if you have time. Now, obviously, I will have an elevator controller, which will say that, bro, all these elevators I will cater and manage on all these floors, and with this scheduling strategy. Obviously, I have this constructor. Technically, this is not a good practice of giving a strategy, hard coded. It should ideally be passed in from a constructor. But again, right now, just for the sake of wrapping it up and keeping it concise, we just added a hard coding here. But again, as I mentioned, it's not good practice to hard code anything whatsoever in your classes. Now, the main thing is request external floor. So this is when you are requesting an external elevator, and this is when you are requesting a floor. The only thing is that as you are requesting a specific, again, right now, a small catch is that we are passing in the elevator ID, which means that in the entire explanation, whatever I told, imagine that you only have one elevator in the system. Now you might ask, Harin, this is something weird. We didn't imagine that. We didn't expect that. Yes, but it's very easy to cater multiple elevators. How? Considering that you know everything for one elevator. Let's say you know the look algorithm for one elevator. So imagine that all people will, just be requesting for one elevator. Or maybe imagine that as soon as you press a up or down, then all the elevators will get the same notification. Then all the elevators will decide that, considering their own algorithm and their own commands which they have right now inside them, or the people inside them, how much time will they take to cater that specific person. And then any one of them can decide, okay, I will take the least time. So you can show that, okay, I can go to elevator 5 or let's say elevator 6. Although in most cases you will see that in a hotels you will have 4 elevators at one place. So if you press, let's say, up or down, all 4 will show which one to go. In malls and stuff, you will have only 2 elevators. Which one to go, you will see. So obviously, both of them are checking that based on my internal request, who can handle external request faster. And both of them will run the same analogy, same algorithm. It's just that whoever feels like, okay, I can cater it faster, and how they will feel, they will simply compute that, okay, imagining this request comes in currently with my current state, how much time will it take? And when I say how much time, simply take elevator movement from one floor to next floor will have a fixed time and fixed capacity, fixed request. Then obviously how much time it will take. Based on that, they can decide that who will cater the request. That's how easy it is. So right now, for simplicity, we will pass in that, okay, this is the elevator which I am requesting for. Cool. Now again, this is something I'm requesting for. It doesn't necessarily mean I will jump inside the elevator. Obviously, in that, how it is handling the request now will be what I saw or what we saw above. Cool. And the same thing, requesting a floor is kind of requesting internal request. That obviously destination floor. This is a pickup floor and corresponding direction as well. Cool. And obviously this step is nothing but you're just simply calling this step, which will say, bro, just simply, if the request is not empty, just kind of simulate the process of pending requests, whatever you have. Whatever request you have pending, just simply get the next step and get the next stop. And then if it's not, then move to next stop. Move says that simply simulate the movement. If you go back, you remember that you are just simulating the movement. Make sure that I will show you just in 3 minutes from now, I will show you that you are calling the step method just to simulate the movement of all the elevators. Cool. Now let's go down and let's come to the building. Building is simply saying that, bro, I will have all that stuff, and also I will have a elevator controller. Again, as you'll see, I have hard coded it here. Not a good practice, but yeah, we can accept that as a constructor parameter. Now comes the fun part, which is the main part. Main part says that, bro, I will have a simple observer. I'll simply add it. Again, controller, building, all that stuff is already made. Then comes that I will just give the user a choice, whatever you want to enter, and then he will, okay, he wants external request, do that. Make sure that you request external request from the controller. Same way if it's internal, that do request the floor. Now, as I mentioned, in 3 minutes, I will tell you this is simulating the movement of the elevators. Just step. Step will call individual elevators move, and move will actually do that movement of simulation of printing out stuff. And obviously, when I say printing out, I will simply display the elevator status, whoever wants to call it. Simple helper method. And this is kind of strategy which I want to plug and play different strategies. I can do that as well. And with that, you have literally achieved one of the hardest problems. Not one of the hardest, but yeah, pretty tough, tricky at least to explain to your interviewer. Can take a lot of your time. Now, obviously, the approach which I verbally told will literally be scalable, modular, flexible, clarity will be immensely there. Although the code which we wrote right now, because I wanted to focus on, the most basic thing, the code is not that much extensible because obviously there are a couple of hard codings there. But if you remove that and whatever I verbally told, if you keep that, then it's a very good code which you will be able to achieve. And again, at the same time, I always say that in any of the places, interview and stuff, verbally tell stuff, but write on focusing the main point. Main point was writing the algorithm, which is, I'll say in this case, look, algorithm. Now, if I want to add any new elevator types, because if you remember in the very beginning, the interviewer told that I can have express elevators or service elevators. So obviously I can make use of factory to make different kind of elevators. So obviously I will have elevator factory. I can make express elevators or service elevators or even normal elevators. So what I will do, I will simply extend the elevator, and again I can just have corresponding, own logic of how express will kind of move fast. That's the only thing, right? For express elevators. Same way I can have for service elevators as well. The catch is that I will use factory just to initialize those elevators. That's a good practice for us. And obviously, this is how we can use or leverage factory to create new elevators in the code. Now, what else we can do? Obviously, we can use design patterns, or we can use new scheduling strategies. They can be literally many. They can be energy efficient strategy. They can be round robin strategy. They can be many strategies. Although I will not discuss because none of them is required or even makes sense. It's more of a business logic. Whatever you want to pick up, you can pick up. Same way for energy efficient. Whatever you think of as energy efficient, you can just pick up that specific strategy here. Totally doesn't make sense, but yeah, you can just pick up anything. And that's how you were able to achieve new types of elevators and new strategies as well with having maintainability and flexibility. Cool. I hope you guys liked it. Again, it's a very big video and I knew it's going to be big because of the fact I wanted to deep dive into FCFS, scan and look, all three of them in deep with the same example so that you understand it and you can explain it to someone else as well because no one else will do. Bye bye, take care. Let's make sure that we hit the like button to flex. Bye bye, take care.